Uh, Good evening, everyone. I am Animesh Burman from Tezpur University Research Scholar Physics Department. I am going to discuss about the non-zero theta on 3, deviation of tri-bimaximal neutrino mixing, and A4 discrete flavor symmetries. Here we study simple modification of the alternative critically A4 discrete flavor symmetry model with the inclusion of an additional flavor that we included in ourselves. The modified model leads to the deviation of the exact tri-bimaximal neutrino mixing pattern by producing a non-zero theta 3 means reactor angle it is, which is consistent with the recent experimental results. We discuss various relations among different parameters in our model. In our model, there are 4 parameters that I will discuss later. We have discussed 3 sigma range of neutrino oscillation data to fix all the parameters in our model. Standard model is very popular model, but despite the great success of the standard model of the elementary particle physics, the origin of flavor structure, masses and mixing between generations of matter particles are still open questions. In standard neutrino scenario, 3 active neutrinos are involved with 2 mass scale differences, 3 mixing angles, and 1 Dirac phases. 3 mixing angles means theta 1 3, theta 1 2, and theta 2 3. And our here main aim is to find out the theta 1 3. Earlier, actually before 2012, it was assumed that theta 1 3, that means the reactor angle is 0. But later, after 2012, there are a few experiments showed that it is not equal to 0, it is near about 9 degree. And we will discuss in our model about this, and this is called deviation of the TBM. If theta 1 3 is 0, that is TBM, but we need deviation of the TBM. So I will discuss here this. So in our framework of the model, we consider A4 model here. The non-abelian discrete symmetry group A4 is a group of even permutations of 4 objects. So we will get 12 elements, and it can be generated by 2 basic permutations S and T having operations. This means S square equal to T cube equal to ST cube equal to 1, and the group representations include 3 one-dimensional unitary representations, 1 prime and 1 double prime, with the generators of S and T given respectively as follows. Means one such that 1 means this 1 prime and 1 double prime are singlets only, because in A4 we get 3 singlets and 1 triplets. So 1 is such that S equal to 1, T equal to 1, 1 prime S equal to 1, T omega square, and 1 double prime S equal to 1, T equal to omega. And a 3-dimensional unitary representations we have shown here just like this, T equal to 1 0 0 0 omega square 0 0 0 omega, and S equal to 1 by 3 minus of 2 2 2 minus 1 2 2 2 minus 1. And here omega is the cube root of unity, and the multiplication rules correspond to the specific basis of 2 generators S and T are as follows: 1 cross 1 equal to 1, 1 double prime 1 cross 1 prime equal to 1, 1 prime cross 1 double prime equal to 1, and 3 triplet multiplication is just like this: 3 into 3, 3 cross 3 equal to 3, 3a, a means asymmetry, and 1 prime and plus 1 double prime. And for 2 tuplets, a and a means we can consider a equal to a1, a2, a3, and b equal to b1, b2, b3, and we have derived as our singlet 1 equal to ab, a1, b1 plus a2, b3, and plus a3, b2, and 1 prime is similarly a double ab prime, a3, b3, a1, b plus ab, a1, b2 plus a2, b1, and 1 double prime is ab prime equal to a2, b2 plus a1, b3, and a3, b1. And here is this is the 3 means for triplet we have considered AB simultaneously, and this is the rule, and it is for anti-symmetry rule. And for whenever we will get means this is the rule which we will use in our model. So here main thing is that this is the particle content whatever we discussed, means up to this, means here lepton doublet, charged lepton, scalar means Higgs doublet, and these are the 5 are the singlets, but these 2 are flavons in our case, and this xi prime and xi are 3 singlets in our case. So, and these are the vacuum expectation value of these. And so to get the motivation of our model, we have added extra particle rho, and its vacuum expectation as v rho, and we will get some unwanted terms may come in our Lagrangian. So we, to constant them, we constant those, we added to z2 into z2 prime symmetries we included, so that unwanted term we can constant. So this is the Lagrangian form, but in our case Lagrangian will be something different, because we included this row extra particle, and this is the vacuum expectation value, and we will get some modified Lagrangian. And here the charge electron mass matrix for that above Lagrangian is just like this, equation number 3, and in general the where all the C singlet 6 as well as 5s are present, the neutrino mass matrix is just like equation 4. And this is the means A, B, C, D, epsilon, M naught. These are the model parameters, and what is M naught, A, B, C, and D we have described here, and phi s we have written just like this: V phi 1, Vs1, phi s, Vs1, Vs2, Vs3, and these are the vacuum expectation value of 3 singlets: xi prime, and xi double prime. This just like this, and HD. This is the, and epsilon is the cutoff scale of our theory. So we will get the modified, means for perturbation term we will get just like this. This is the our perturbation term, which will bring to the modified Lagrangian, and as well as the modified TBM. Means then the symmetry will break, and we will get the modified TBM. So in our case, this is the perturbation term we have calculated, and which will later will bring the perturbation term. So whenever we discuss in our model, we get this 3 parameter we have discussed here, means correlation among our model parameters. This is one B versus T, and one is B versus epsilon. Epsilon is our perturbation term, and D versus epsilon. Okay. So this plot is shown that everything is in our range, and this one is matching with the experimental data. So the discrete symmetry group A4 is very useful for explaining the masses and mixing pattern of the neutrinos among the charged electrons. We have detailed made detailed phenomenology study of the validity of the different mass matrices that can be generated by spontaneous episymmetry breaking. And our result shows that the neutrino masses are naturally small, and little deviation from the tri-bimaximal neutrino mixing from that can be realized, and everything, this deviation actually comes from this perturbation term, and it will give the modified TBM X, and this is only the main work. And here also I studied the NDVD phenomenology, but I have not covered here. So NDVD phenomenology is also matching with the experimental results, and right now I am doing for del CP also. And so here I have shown only the model correlation among the model parameters here, and it is matching with the experimental results. And thank you.